Hi everybody, this is Mr. Schneider, and today's lesson we're going to talk about proportions in a right triangle. When an altitude is drawn in a right triangle from the right angle to the hypotenuse, it creates a situation where you have three similar triangles. The small triangle, triangle ABD, is similar to the medium triangle, triangle DBC, which is similar to the large triangle, triangle ADC. And since these three triangles are similar, we can set up proportions to find the lengths of segments. One way to set up these proportions is to use a table. I strongly recommend it to people, where we set up a 3x3 table. I call the columns small, medium, and large for the small triangle, triangle ABD, the medium triangle, triangle DBC, and the large triangle, triangle ADC. So in the small triangle, the medium triangle, and the large triangle, I differentiate the side names by calling them the short leg, the long leg, and the hypotenuse. Remember, the legs of a right triangle are the sides that make up the right angle. So in the small triangle, segment AB is the short leg, and segment BD is the long leg, and segment AD is the hypotenuse. The way I tell the difference between the short leg and the long leg is just visually. In the medium triangle, triangle DBC, the short leg is segment BD, the long leg is segment BC, and the hypotenuse is segment CD. The large triangle is a little bit tricky because it's upside down. Remember, your legs form the right angle. So segment AD is the short leg, segment CD is the long leg, and then the hypotenuse runs all the way from A to C. So the hypotenuse is segment AC. If you take a look at this table, as long as you pick segments that line up together, you'll always be able to write a true proportion. So for example, if we were to just look at the upper left, AB over BD is always going to be equal to BD over BC. If we look at the upper right, BD over BC is always equal to AD over CD. If we look at the lower left, BD over AD is equal to BC over CD. In the lower right, BC over CD is equal to CD over AC. And really, it doesn't have to be in a corner. It could be anywhere as long as it lines up. So AB over BD is equal to AD over CD. Or BD over AD is equal to CD over AC. You can even go with the four corners. AB over AD is equal to AD over AC. So we can use this table to solve problems to find side lengths. And here are a couple examples. In the first example, we're given that AB is 6 and that BC is 10 and that we're asked to find DB. So I labeled that on the diagram. AB is 6, BC is 10, and then I created my 3x3 table with the small, medium, and large for the triangle size. Small triangle, medium triangle, large triangle, and then short leg, long leg, and hypotenuse as my rows, which are my side lengths. So in the small triangle, the short leg is 6, the long leg is X, and I didn't know the hypotenuse, so I left that blank. In the medium triangle, the short leg is X, the long leg is 10, and I didn't know the hypotenuse, so I left that blank. With the large triangle, I don't know the short leg, I don't know the long leg, and the hypotenuse is this entire side, so that's 6 plus 10, which is 16. As it turns out, that 16 isn't useful to me at all because it doesn't line up to form a proportion. But 6 over x does line up with x over 10, so I use that as my proportion. To solve the proportion, I cross multiply. 10 times 6 is 60. X times x is x squared. To solve, I take the square root of both sides. When I simplify the square root of 60, I split 60 into 4 times 15. The square root of 4 is 2, so I have 2 radical 15 is x. I was asked to find dB. Well, dB is x, so dB is 2 radical 15. In the second example, I was given that AB was 9 and BC was 16, so I labeled those on the diagram. I was asked to find AD, so I called AD x. I know by the partition postulate that the parts add up to the whole, so AC has to be 9 plus 16, or 25. Again, I set up my 3 by 3 table with small, medium, and large, which are the names of my 3 triangles, and short leg, long leg, and hypotenuse are the side lengths on those triangles. In the small triangle, the short leg is 9. I don't know the long leg. The hypotenuse is x. In the medium triangle, I don't know the short leg. The long leg 16, and I don't know the hypotenuse. In the large triangle, the short leg is x. I don't know the long leg, and the hypotenuse is this entire side, which is 25. So again, I look to see where things line up. 9 lines up with the x lines up with the 25, so I just set that up as my proportion. 9 over x equals x over 25. I cross multiply. 25 times 9 is 225. X times x is x squared. I take the square root of both sides to get 15 equals x. I was asked to find AD, and since x represents AD, AD is 15. Hopefully this is a good lesson for you and you're able to get to some of these examples on your own. Good luck.